If you've ever been at the helm of a boat, you know that classic feeling. You're staring at these big, beautiful, but kind of fuzzy analog gauges.
Yeah, and you're trying to piece it all together, right? Like triangulating three different needles just to figure out if the engine's happy and you're not about to run into something.
Exactly. Well, those days they're fading fast. We are definitely in the age of the digital co-pilot now.
We are. And that's what we're doing a deep dive on today. Electronic Vessel Control, or EVC. It's basically the powerful, centralized computer brain in modern marine gas engines.
And our mission for this one is pretty straightforward. You got us the EVC operator's manual, and we're just going to pull out the core philosophy. We want to know how it works, how it seriously boosts your safety and efficiency.
And, how you can actually use that information center to be a smarter captain.
Right.
And I think we should probably set the stage with the company behind this, Volvo Penta. I mean, they've been doing this since 1907, and their entire philosophy boils down to just three things: quality, safety, and environmental care. The EVC system is really where all three of those things come together on the water.
Okay, so cut through the marketing for us. What is EVC really?
Think of it like a boat's central nervous system. It handles all the instruments, it detects faults, and it gives you all your warnings from one single place. There's a computer that's just constantly monitoring data, streaming in from the engines, the drives, the sensors, everything.
So if that's the definition, what's the one single biggest benefit for a captain? What's the takeaway?
It's safety. Hands down, it's safety. Its core job is to make sure every system is running within its normal parameters. It's not waiting for a failure. It tells you the second something deviates, so you can be proactive, not reactive.
Okay, I like that. Let's unpack this dashboard then. Let's start with the very first thing you do. You turn the ignition key. What happens?
So the first thing you'll hear is this audible check. Two really short beeps. And then you'll see the icons on the alarm status indicator. Those are the dedicated warning lights. They light up in sequence and then go right back out. It's a system's own self-test.
Like a pre-flight check.
Exactly. It's confirming all the connections are live and ready to go.
I noticed something really interesting in the manual about power management. It says when you're actually cranking the engine, the EVC cuts power to the main gauges. Why do that?
That's just smart engineering for being on the water. It's all about limiting battery draw. Starting a big marine engine pulls a massive amount of current.
Sure.
So by, temporarily shutting off non-essential things like the gauges, it dedicates every last amp to the starter. That as soon as the engine catches and you let go of the key, boom, everything powers back on to the last screen you were on.
That's a great little detail. Okay, so looking at the helm itself, you've got four main physical parts here that you interact with.
Yep. First up, you've got the button panel. Super simple. Up and down arrows to scroll, a right arrow to, go into a submenu or confirm a change.
And the left arrow to back out.
Exactly. Back out or cancel what you were doing.
Then you have the main event, the tachometer with that built-in LCD screen.
Right. So you still get the classic needle for your real-time RPM, but the digital heart of the whole system is that LCD screen right in the middle of it. That's where all the menu data lives.
And then you have that, what's it called, the alarm status indicator?
Crucial. That's your dedicated visual warning system. For the gas engine version, you're really watching four lights: oil pressure, voltage, coolant temp, and the big one, the general warning icon.
Okay, that general warning icon. That sounds like one of those check engine lights that could mean anything. Is it just a vague warning?
Well, yes and no. It does light up for a whole range of things like low water depth, high exhaust temp, low fuel, wrong drive trim.
It's a lot of things.
A lot. But here's the smart part. The second that light comes on, the EVC automatically forces the LCD screen to switch away from whatever you were looking at to a text screen that tells you exactly what the fault is.
Ah, so no guesswork? The light gets your attention and the screen gives you the diagnosis.
Precisely. It'll just say low fuel level or trim electrical fault.
Okay, let's get into that data then. The main menu, I saw something in here that's a classic source of anxiety for boaters: water depth.
Oh, yeah. And the way EBC handles depth is, it's really smart. It's not just spitting out the raw number from the transducer.
It's that offset feature, right? Explain how that works in the real world.
It basically lets you eliminate that shallow water anxiety. Let's say your transducer is mounted 3 feet below the water line. You can go into the settings and add a positive 3-foot offset.
So now the display is showing you the true water depth from the surface, not from 3 feet under your boat.
Exactly. Or you could do the opposite. If you know your keel draws 5 feet, You can set an offset, so the number on the screen is always showing you the actual clearance you have under the keel. It just does the math for you.
That is a fantastic safety feature. Okay, what else is in that main menu? I see some efficiency readings.
This is where that environmental care pillar comes in. You get instant fuel rate, so gallons per hour, and the one I really love, instant fuel economy.
So miles per gallon.
Or nautical miles per gallon, yeah. This gives you that real-time feedback loop. You can nudge the throttle a little, adjust the trim, and instantly see on the screen if you just found a more efficient cruising speed. It's like a coach for saving fuel.
It kind of gamifies it. I like that. All right, let's switch over to the gauges menu. This is where the hardcore engine health numbers are.
Yep. And these readings come from what the manual calls serial data link gauges. These aren't your old school, slow-to-react analog gauges. They're high-accuracy digital sensors giving you instant, precise data.
What are the two vitals you should always be keeping an eye on in here?
Coolant temp and oil pressure, no question. They are the absolute fundamental vital signs of your engine.
But there's a big catch here, right? EVC gives you the number, but...
Yeah. But you have to know what normal is for your specific engine. You have to check your engine manual. If it reads 210 degrees, you need to know if that's perfectly fine for your engine model or if it's about to overheat.
Got it. We also get a digital RPM readout here, battery voltage.
And that voltage reading is neat because it shows you the battery level when the engine's off, but when it's running, it shows the combined output of the battery and the alternator.
And then there's boat speed and, for stern drives, trim position.
Right. The trim shows you the tilt of the stern drive. But the manual's really clear on this. If you have an inboard engine, that trim position screen just won't be there. It's irrelevant, so they take it out of the menu.
Makes sense. Okay, so once you're up and running, the EVC starts to analyze your performance over time. Let's talk about the trip log.
Yeah, the trip data menu is basically your report card for the current journey. It's tracking things like your average fuel rate and average fuel economy since the last time you reset it.
And that's often more useful than the instantaneous numbers for planning a long trip.
Way more useful, yeah. It also tracks trip time, which goes up to almost 1,000 hours, and your estimated trip distance and total trip fuel used. It's perfect for figuring out the real cost of a voyage.
Okay, and there's a really important be careful note in the manual here about resetting this data.
Oh yeah, this is a big one. You might think you're just resetting one thing, like you hold the button down on the average fuel rate screen.
And you've just wiped the whole log.
The whole thing. Distance, time, fuel, everything gets zeroed out at the same time. Thankfully, there's a confirmation step, so you can't do it by accident. But you have to be aware.
That's a good tip. Now, in the settings menu, this is where you really customize it for your boat. The depth alarm seems like the most critical safety setting in there.
Absolutely. You can set a minimum depth, say 5 feet. The second the transducer reads less than that, you get an audible alarm.
And it's smart enough to turn itself off once you're back in deeper water.
Yep. After about 5 seconds, it resets, so it's not just beeping at you endlessly.
Yep.
And you can use that depth alarm offset we talked about to make sure the alarm is calibrated perfectly for your boat's draft.
Right. And you can also adjust things like the screen brightness and contrast.
The contrast one is actually pretty important. If you've got direct sunlight hitting the screen, or it's really cold out, that can wash out the LCD. Being able to adjust the contrast on the fly is key to keeping the data readable.
And finally, you can switch all your units around, right? English to metric.
Yeah, miles to kilometers, gallons to liters. And for speed, you can choose between nautical knots and nautical miles per gallon, or standard statute units like mph and mpg. It's super flexible.
Okay, let's get to the most critical function. What happens when things go wrong? The EVC has this 3-layered warning system.
It does. It's designed to be impossible to miss. You get an audible alarm, which is the buzzer. You get a visual alarm, which is the icon on the status indicator. And you get a textual alarm, the actual description on the LCD screen.
So how does it differentiate between a minor issue and a shut the engine down now emergency?
That's the difference between red lamp alarms and yellow lamp warnings.
Red lamp sounds serious.
It is. A red light means an immediate threat. It's accompanied by a constant nonstop buzzer. You have to take action right away.
Like what kind of situation? Give me an example.
Low oil pressure. That means potential engine damage is happening right now. Or high coolant temperature, which could be a blocked water intake. The response is almost always to reduce speed immediately or shut down the engine to prevent catastrophic damage.
And the yellow lamp warnings are less dire.
Generally, yeah. They give you 3 short beeps instead of that constant drone. It's for things like low fuel or a minor electrical fault. Still important, you don't want to run out of fuel, but it's not demanding an immediate shutdown.
So if you get that constant screaming red lamp buzzer, what's the very first thing you should do?
Acknowledge it. You press the left arrow button to silence the buzzer. That's critical because it lets you think clearly and focus on the text on the screen without that deafening alarm in your ear. Silence the alarm, then deal with the fault.
Okay, here's a key question about how robust the system is. What if the EVC system itself has a major fault, like a short circuit? Does your boat just die in the water?
No, and that's a
Okay.
key design feature. If the main EBC system goes down, you still maintain your most critical functions. Engine operation and throttle control are still active, you can get home.
But you lose something important, don't you?
You do. If the EBC has a total fault, you lose the ability to trim the drive. You have steering and you have propulsion, but you can't adjust the angle of that stern drive. It's a major loss of control and really reminds you how central the EBC is.
Okay, let's run a quick troubleshooting drill. The engine won't start and the screen says voltage low. Where does EVC point you first?
Well, you check the battery voltage, obviously. But then you look for the simple stuff EVC is hinting at. Corroded connections on the battery terminals, maybe a snapped alternator belt, or a blown fuse. It helps you isolate the likely suspects fast.
What about if the screen says drive trim high and the boat is doing that violent bouncing thing? Porpoising?
That's usually just an operator issue. You're trimmed too high for your speed. The solution's simple. Trim down. Or if that doesn't work, just reduce your engine speed.
One last little logic puzzle. The fuel level low alarm comes on. You pour in 5 gallons from a spare can. Does the alarm go away?
It does not. Not immediately. And that's on purpose. The system won't reset the alarm until you've recycled the ignition, turned the key off, and then back on again. It forces the system to take a fresh reading of the fuel sender to confirm the problem is actually solved.
So when you boil it all down, EVC really does change the whole experience. You go from just looking at a few needles to having this digital co-pilot that's always monitoring, optimizing, and protecting the vessel.
It really is the foundation for better safety, better quality of operation, and, frankly, better fuel efficiency.
Before we wrap, we do have to pass along a specific safety note from the source material itself. It's the California Proposition 65 warning.
Right, it's an important one. It just notes that engine exhaust and some of its components are known to the state of California to cause cancer, birth defects, and other reproductive harm.
Okay, so EVC gives you this incredible real-time control to optimize a single trip. But I want to leave you with a final thought about longevity. We've talked about all this data engine hours, coolant temp. If your goal is to maximize engine life over years and years, what data points in the EVC are the most powerful tool for that long-term preservation?
It's the combination of the long-term data with the instantaneous data. It's watching your coolant temperature and oil pressure over the lifetime logged by the engine hours. The real power isn't just knowing your temp right now. It's noticing that over hundreds of hours, your normal operating temp has slowly crept up by 5 degrees. That's your early warning. That's the trend that tells you it's time for service before a small issue becomes a massive engine-killing failure down the line. That's the real power of having this much accurate data at your fingertips.